Video today we are going to discuss about the cryptography and network security. In that DES we will discuss about this in this video. DES means a digital encryption standard. Overview of this video is overview of cryptography, classical symmetric system, substitution cipher and transposition cipher, product cipher method, and modern symmetric cipher method. We will see basic technology, plain text, original message which is going to sent by the sender is known as plain text, and ciphertext, the coded message is ciphertext. Cipher, the algorithm for transforming the plain text to ciphertext. Key information used in cipher known only to sender and receiver. In cipher encrypt converting plain text into ciphertext. Decipher is a method which is recovering the plain text from the ciphertext. And cryptography is the study of encryption principles and method. Cryptanalysis code breaking is also known as code breaking, the study of principles, methods, and deciphering the ciphertext without knowing the key. Key will not be delivered, but without the key, they will know what is the algorithm and what is the message sent by the sender to it. And cryptology, the field of both cryptography and the cryptanalysis, is known as cryptology. Fiscal cipher structure implements an SP network concept based on the invertible product cipher processed through multiple rounds, which partition the input block into two halves, perform a substitution on left data off and based on the round functions of right off and subkey, then have permutation swapping off. These are the some functions will occur in the fiscal structures. Data encryption. This fiscal cipher structure is used in the data encryption standard. Data encryption standard is published in 1977, standardized in 1979. The key is uses 64-bit quantity, 8-bit parity bit plus 56. 56 plus 8 is 64-bit. Every 8 bit is a parity bit. 64-bit input is given to DES 56-bit key, and we are getting the ciphertext 64-bit. DES overview. 64-bit input is given to permutation, and round 1 to round 16 also there. For each and every round, K1 to K16 is used. In order to generate the key, 56-bit key is used. After the end of round 16, swapping method is used. That is, left bit is swapped to right, right bit is swapped to right, left bit like that. And final permutation will occur. After that only we are getting the output. This is the overview of the DES, and this is the permutations, that is 1-to-1 permutation, that is shifting of operations, that 11th bit or 1th bit is going to 6th bit, like that. Bit permutation will occur. And then this is the per round key generation, initial permutation of DES key. After that, C bit and D bit, 56 bit is divided into two of 28 bit and 28 bit. This left side 28 bit is shifted left shift circular, and of that permutation with the discard operations is occur. And right bit is circular shift operations, and we are getting 48 bit. This is directly given to 28 bit. This is given for the next round 28 bit, and this second of right off is directly given. Round 1 to 9 16 has single shift operations. Others, that is 3 4 like that. In what are the left 16, and these rounds have 2 bits shift operations. Each and um, every round this key is generated. This key is given to encryption operations. And this is the DES round key, 32 bit, 32 bit, and here expansion operation. Here 32 bit is given to this expansion, and then we are getting 48 bit as output. This is the Mangler function, and then S box. S box is known as selection box. 48 bit based on the key, this permutation selector. This left 32 bit is given directly to XR operation. This right bit is given to this Mangler bit, and before given to Bangalore function, this bit is taken and directly given to the next round or left bit. This after the functions, this is directly given to right bit, that is left and right shift operations also are called. This is the one round encryption process. Like that 16 rounds will be occur. This is the Mangler functions. This expansion key 4 bit is given to the functions, and we are getting the 6 bit as output. And this is the selection operator. S box 8 S boxes is there. S1 to 8, S7, 8, S8. This is the spread operations. We see this S box have 6 input and we are getting 4 output. First bit and this last bit is used for row identification, and remaining 4 bits are used for column identifications. So 48 bits is given 8 into 6, we are getting 8 into 4, that is 6 bits are inputted to the each and every input, and we are getting by means of selection we are getting 4 output, 4 8 from the each and every S box, 8 S box, and we are getting output 4. 8 into 4 equal to 32 bits. That is 48 bit is converted to 38 bit. So 2 bit is used to select among the 4 substitution. For the rest of the 4 bits are quantity. Okay. DS standard cipher iterative action key generation box. For a cipher operations, input is 64 bit, and key 48 bit, output is 64 bit. For key generation, 56 bits input and output is 48 bit. DS, for simple, it is easy to implement hardware gigabits per second and software megabits per second level. We can achieve DS, and 56 bit key DS may be acceptable for non-critical application, but triple DS, DS3 or triple DS should be secure for most applications today. It also supports several modes: ECB, CBC, OFB, and CFB for different applications. ECB is electronic code book, and CBC is ciphers, blockchaining, and OFB output feedback mode, and cyber feedback mode. These are the modes of operations of DES. This is the outline of what is the strength and weakness of DES, AES, and also public key cryptography, modern arithmetic, and RSA algorithm. We will see. This avalanche effect develops key desirable properties of encryption algorithm, where a change of one bit in the one bit input or key bit results in changing more than half of the output bit. This is known as here any other 64 bit we are having. Any one bit change means the output will have more changes. DS exhibit a strong avalanche effects. And strength of D is key size 56 bit key size. So we have 2 power 56, 7.2 into 6, 10 power 16 values are there. Brute force such looks hard because checking whether one by one is taking more time. Recent advances have shown is possible. In 1997, on a huge cluster of computer over the internet of few months, they break. And also in 1998 also dedicated hardware called DS cracker is used by EFF in few days. In 1998 99 above combined in 22 hours they break. Still must be able to recognize the plain text, so no big flaw for the DS algorithm. And DS replacement triple DS 168 bit keys are used 48 48 48 56 56 56 64 64 means 56 56 56 56 168 3 into 56 168. No brute force attack. Underlying encryption algorithm the same. No effective analytic occurred. Drawback performance: no efficient software codes for DS attributes. Efficiency and security: bigger block size desirable. Advanced encryption standards used in NIST US National International NIST standard issued a call for cipher in 1997. Prigentile was selected as the AES in October 2000. This method is chosen. AES private key symmetric block cipher. This 128-bit data is used. 128, 192, 256-bit keys. Stronger and faster than triple DES. Provides full specification and design details. Evaluation criteria, security, effort to practically cryptanalysis. Uh, if we want to break or analyze, we have to take more effort. Cause computational efficiency and memory requirements are there. Algorithm and implementation characteristics, flexibility to app, hardware or software, suitability, simplicity. And we move on to in this we saw about the strength and weakness of DES and AES. And now we move on. Private key cryptography. In private key single private key cryptography is also known as private key or secret key or single key cryptography. Uses one key shared by both sender and receiver. If this key is disclosed, communications are compromised. Also, it is asymmetric, that is parties are equal, hence does not protect the sender from receiver, forging a message and claiming it is sent by the sender. Public key cryptography, probably most significant advance in the 3000 years history of cryptography, uses a two key, a public and private key, asymmetric since priorities are not equal, uses a clever applications of number theoretic concept functions, complement rather than replaces private key cryptography. That is, private key cryptography also used and public key cryptography also used. Public key cryptography, public key or two key or asymmetric cryptography involves the use of two keys, a public key which may be known by anybody and can be used to encrypt the message and verify the signature. A private key known only to the recipient used to decrypt the message and sign create signature asymmetric because those who encrypt the message or verify the signature cannot decrypt the message or create the signature. This is the architecture of the public key cryptography. Here Bob's want to send a message to allies. Then Bob is having more number of public key. With the means of allies public key, he encrypting the plain text to ciphertext. The plain text is using the allies public key encrypted algorithm. Maybe we can use anything. The RSA can also be used and transmitted ciphertext with by means of allies private key only he can able to recover the decryption algorithm and he can able to read the message. This example for this email is the good example. For email we are logging into our system and after that for whom we want to send we are putting their email id and sending the message to that person and there also the other party also they are enter into their login by using their private password and after he is receiving the message from he can open that message. Okay, email is the best example of public key cryptography. Public key cryptography characteristics. Public key algorithm rely on two keys with the characteristic that it is computationally infeasible to find the decryption key knowing only algorithm and encryption key. Computationally easy to decrypt the message when relevant decrypt key is known. Either of the two related keys can be used for encryption with the other used for decryption in some schemes. Public key crypto system source A and source B. Message source from message to X is given to encryption algorithm. After the encryption algorithm, we are getting the Y encryption algorithm. Here, key pair source. By this key pair source, KRA means key A private of A. U means public, U of A. That is, A party's private key is used to encrypt, that is, enter into the system. By for encrypting, from this pair key is used. That is, destination party's public key used. This is the email ID like that. we are sending the information and decrypt using the is private key. So B is private key, K or B, and uh, after entering Y he is getting decryption algorithm, yeah, and he is getting the message from this source. So KUA, he only knows is public key, that is source B is knowing source A's public key, and source B is private key, and he is getting the message X. Two major application, encryption and decryptions, provide the secrecy, and digital signature also. The digital signature provides the authentication. This is comes on very interesting topic. Public key algorithms are based on modular arithmetic, modular addition, modular multiplication, modular exponentiation, modular arithmetic, addition modulo mod k, poor cipher with dk plus dm mod k. Example, if k equal to 10 and dk is the key, here plus 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Up to 9 we can get. 10 will not be wherever 10 is 0 plus 0 0 0 plus 1 0 1, like that it will comes. When 0 1 plus 9 10, instead of 10 we are writing 0. Okay, modulo operator like that. 2 3, here see, 9 after that 9 0, and 9 plus 2 9 plus 2 11, 1 only remainder. What is the remainder? We have to write 9 minus 9, here 0, 9 11 minus 9 1, 10 minus 1 1, 11 minus 9 2, like that. Additive inverse addition mod k is 0, decrypt by adding the inverse. This is a modular arithmetic. Modular multiplication is same as previous. Into multiplication operation will taken care by this. 0 into 0 0, 0 plus 1, 0 into 1 0. This row is 0, this row also 0. 1 into 1 1, 1 into 2 2. When it attains after the 9, you see, 2 fours are 8. Okay, 2 fives are 10. 10 means 0. 10 minus 10. Here 2 6 are 12. 12 after the 10, 2 is remaining. So in multiplication, 2 4 6 8 9, this only repeated. In this row, 3 6 9 2 5 1. What is the remainder? You have to write. Multiplication inverse, multiplication mod k yields 1. Only some number have inverse, some number may not have inverse. Modular multiplication, only the number relative prime to n will have mod n multiplicative inverse. Example, 8 and 15 relatively prime. Factors of 8 are 1, 2, 4, 8, and 15s are 1, 3, 5, 15, and 1 is the only common factor. Totient function, we can get the totient function, number of integer less than the n relatively prime to n. If n is prime, pi of n, totient function is represented as pi of n equal to n minus 1. If n equal to p into q and p and q are primes, p is not equal to q, pi of n equal to p minus 1 into q minus 1. Example, pi of 37 equal to 36, pi of 21 equal to 3 into 3 sevens are 21, 3 minus 1 and 7 minus 1, 3 minus 1 2, 7 minus 1 6, 2 into 6 12. We will discuss about the RSA in next video. Thank you students.